Hello everyone, welcome to the sixth session of SillyHacks. Allow me to introduce SillyHacks to you. SillyHacks is a hackathon built, designed to be silly, to have fun while you are hacking something. You do not certainly have to solve any problem, but you are supposed to network with people and basically have fun. While this is a 48-hour long hackathon, so there's too much to do, and we also have organized similar sessions and events during the event also. So it is going to be a lot of fun, right? So if you haven't registered for SillyHacks yet, you can register and the link is given down below. Now let's continue with today's session. We have with us Sayantan Das. He is currently working as a research associate under CVPR unit, ISI Kolkata. He has pursued his bachelor's in computer science and engineering degree from West Bengal University and graduated recently in July 2020. He has also mentored for Google Code in 2019 in TensorFlow and also has been a former intern at ISRO Ahmedabad in 2019. So I welcome you, Sayantan, and over to his talk.
So what are GitHub Actions? GitHub Actions are a way to automate your software workflows. You can, this is basically, it's a built-in continuous integration, continuous delivery. These kind of softwares are run on the backend on either Linux, Mac, Windows, or it's running on a Docker container. So these are very easy to share, easy to write. You can use environment variables. I will in this workshop we'll tell you how to create those environment variables and share them as secrets. They're also called GitHub secrets. Through these workflows, you can generate various PDF files, various metrics, graphs, plots. So these are all your artifacts. So you can store these artifacts like you have releases tab in your GitHub repo. You might have seen what releases are. Those are actually the versions of your software. So more versions you have, your release version will keep on changing, like 0.1, 0.2, and then you go to 1.0 and hence. So either these are hosted directly on GitHub or you can host them on your own. Those are called self-hosted runners, where you host them on your own. And these are event driven or they might be schedule driven. So what event driven is, for example, there is a push that was created, or there was a pull request created, or there's an issue. So those are your events, and only on those events, those act as the trigger when these workflows will work. Or they might be schedule driven, like um, it's like at a certain point of time of the day or certain day of the week, your workflow will run. So I'll talk about both of these two examples in the upcoming slides. So getting started, this is how it looks like. We'll go straight off to the demo. So what you do is first you start off with checking what this is how actually the workflow looks like. These are all your steps of the these are your steps for the workflow. First you set up and then you run this checkout. So this checkout action is a very basic template action. What this actually does is it checks out the GitHub repo that you're running. So it's like some virtual machine is running, like for some virtual machine is using this GitHub repo. So it will clone it and then it will get inside that master branch or some branch. So that checkout thing is basically that. So after that, you head to the Actions tab on your repository. So you get to see the different actions that you have already deployed, you have already created. If you have not created, then you'll see a build and test your repository. So you'll be able to set up your workflow there itself. So you start off with a template. You will see on the right there are many templates. So you can click on any of those templates and you can start off from there. So what actually a workflow is? We have been talking about workflows in the last few slides. So what actually is a workflow? A workflow is actually a process. So it's actually an automated process, and you can actually set it up in your repository. So for example, there are many types of workflows. Like those can be organizational, which actually welcome new contributors. Those can be legal, where you need a license uniformity, and that's what these workflows will ensure that license uniformity is maintained. And application workflows, these test across platform frameworks. For example, if you have an Android application, and what you do in an Android application is build you build the JDK. So you build the JDK and you compile them, you compile the dependencies, and after that you get the APK, right? So instead of doing this in Android Studio, which takes a lot of time and takes a lot of RAM, so when you're working on when you're working in a version control environment where you need to push code again and again. So if you don't want to, like, if you want to just keep on pushing the code and just you don't want to check it, so you want to check whether the build is working or not. So for that, you can set up such kind of a workflow where it on every push it runs the and creates the JDK and then pushes the JDK like the app APK into the releases tab. So that thing we can do with this. So what are these events? So whenever there is an event, then these workflows will be triggered. So as I talked about, event might be a pull request, it could be a push, or like you've made the repository public, or as I talked about the scheduling thing, it's like the cron jobs. So cron jobs are actually automated backend services. These are like you set up a specific pattern that okay, so every day of this month, at every day at 12 o'clock past 1, I'll run this job. So this is how it will work. So every day at 12 o'clock it will work like that. So these are some ways that very common ways you will come to know in the next slides. So what are these actions? So actions are individual unit of work that you can combine as steps to create a job in a workflow. So so you'll see that there are multiple actions that I had talked about in the first slide. That was like the checkout slide. There is this checkout action. So checkout action, what it does is it checks out the GitHub repo, like it gets inside the repo and switches into the master branch. By default, you have the master branch. So there are many actions. As I was talking about, you can actually use these actions. You can publish them on the marketplace. You can publish them as repositories so that other people can use. Easy to write, easy to share. Property is maintained in actions. So you go to the marketplace, you can find many actions. Recently, there is a tweet by Peter Juras, who is a member at GitHub. He has been putting GitHub Actions tip for every day in this month. So you can go ahead and check hashtag GitHub Actions tip on Twitter. You will find all the tips that he's giving. So let's get started. So in the first workflow, we will create a greeter bot that greets like Hindustani bhav. You might have heard of it. It's meme material. So in in the basic workflow, we will. I have already created a repo for you. So you can see. I'll go to the github.github/workflows. Then I'll go to how.yml. So this is the YML file that I created earlier. So I'll show this how this works. I can like change the stuff, change the messages. So I'll explain every line here. So my workflow name is greetings, and then where I'm running it on events like issues and pull requests. So what my workflow will have, it will have a job. So job is, it will have a job label called greeting. It will work on a Linux virtual machine, like it will be a GitHub hosted runner. So it's a Ubuntu latest. You always have the highest functionality when you're using Linux. And what will be the steps? So in the steps, you will be first using the interaction action that's given by GitHub. So it will be needing a secrets. It will be needing your GitHub token. So if you go to the settings, you will not be able to see the settings because I am the administrator. So in my case, I'll show that for settings, you have to go to settings, then secrets. In secrets, you'll see like you can see that it's secrets.github token, right? So this secrets is an environment variable as we discussed earlier. So environment variable are will be required for this case. It's like having a GCC path. Like when you're trying to run a GCC file, or you're trying to run a C or C++ file, you need to mention where your compiler is there. So you need to establish an environment variable. So even here, like you have to create a GitHub token. That's your it's your actually token that actually shows that there's some kind of authorization stamp on whatever that is being happening. So that just nobody can ऐसे ही करके they won't be able to like uh, create their own actions. So what you do is on CDS you create new secret and then you name it as token. See if it's a GitHub token, then you cannot name it as GitHub underscore token. That is your GitHub's official functionality. So you need to name it as token. So I've named it as token, and then you have to fill up a value. So for my case, what I'll do is I had already filled up a value, so I'll just update that value. I'll name it as Sayantan Das. Okay, so that's my value. This is my token ID. So token and your value is Sayantan Das. You won't be able to see it again. So yeah. So report token is this your issue message. What message you are going to show when you create an issue? It's जय हिंद दोस्तों एक नंबर फर्स्ट इशू बना रहेला है तू दैट इज एंड फॉर पॉलिटिकल चिल क्रिएट क्या बोलते हो अभी अपन को टाइम दे थोड़ा देख के बताता ठीक सो यू क्रिएट द इशू you change the token and I guess I haven't made any changes so let's make a change. Uh, yeah, so there's a change. I already created this for you so you can like just plug in and play. So you will be able to see I'll create a new issue. I'll create this issue name is test my bhav. I have to test this bhav. So let's see. I'll see the actions. In the actions I'll get to see test my bhav, and then I'll see this is issue number 3. So you can see issue number 3 is written there. That proves that the issue has been created and then only this action was triggered. So your trigger will be shown there. So let's check the issue. Okay, let's check the issue. Let's see if our action has been completed or not. No, it's still running. So yeah, once it will be completed, then we'll be able to see. Yeah, so if you can see the green tick, then yeah, all the steps in that action has run properly. So we can now go ahead and see the issues. So if you can see the issues now, I guess you should see something. should be shown here somewhere. Okay, its first interaction is only when it's the user's first contribution. No, it's not my first contribution, so you will not be able to see it. Okay, I'll just show you an example of how I worked on it before. So it's like at that time it was my first contribution. So I created Aja Bhav. So you can see the GitHub Actions bot has commented. It's like Jai Hind dosto ek number first issue bana rahe like. Okay. Uh, so this was a very brief intro to the workflow. So you get a warm up regarding how actions should look, actions should work like. So let's see what the next issue is. It's commenting on a commit. Okay. So you create a commit, and on the commit history you will be able to see you can create markdowns on that. So I'll show you how it works. Um, let's go to the repo again. I have all this created earlier for you. So let's go and check out release upload. Okay. So what happens here is in the workflows you'll be able to see this file called comment.yml. So I'll just open and show it to you how you can write this stuff. Okay. So you can see the terminology is more or less same in all actions. It's just some kind of some small changes will be there. So name will be your comment below. You can name anything. So when it will be happening, it will be happening whenever you push a commit. So on the push trigger, push will be the trigger for this event trigger. So the jobs are you have to run. So where do you want to run? You want to run. It's like a story. Where do you want to run? You want to run Ubuntu latest. It's like what steps do you want to run? Okay, so my first step is I want to check out. So you want to check out, you want to get clone and then cd into that folder, and then you want to see it, get checkout master or whichever branch that is. So it will do this. See, whenever you see actions slash no, so these are the official GitHub template actions. If you see some other name person's action, that is like some third party person has created. So then after that you name it as create commit command, and you can see uses Peter Evans commit command one. So Peter Evans has created this GitHub action. So we are using GitHub workflow. We're not using GitHub actions. We are using GitHub workflows where you're using somebody else's action. So as I said, these are easy to write and easy to say. So you can like collaborate with people and you can use other people's actions as well. So Peter Evans creates this commit command. So within this, what you want to do is you want to define the body of your message. So your message is a multi-line command with GitHub Markdown. So it's a Markdown file. It will be shown as a whenever you have a GitHub comment. All these comments that you see on GitHub Actions, issues, on issues and pull requests, every comment is basically a Markdown file if you think so. Okay, so this is actually a multi-line comment. I'm going to write this as Sayantan triggered this again. Okay, so you can see created by Sayantan, so it will create a hyperlink. Yeah. So let me start the commit. I have updated this. I have updated this. It is just a commit. It's not a big deal. So you'll see that this commit has been created. You can see every commit has a commit unique ID, and you'll see on the actions tab that I have updated this. Let me go to the commit history, and you will be seeing that okay, so I've made this change, and below that I'll be seeing GitHub Actions. Look, you can see this. GitHub Actions has committed 11 seconds ago. So you get the hang like how this GitHub Actions can work. So you might be thinking like, okay, so if I'm doing a machine learning experiment, like my run has completed, my workflow has completed. Now I want the reports, I want the classification table, I want the metrics, I want the plot, I want the confusion metrics, I want the graphs, charts, and all stuff. So yes, you can do that. So we'll show it in the next demo. So your next demo is codespell.yml. So this is the last basic, after which we'll directly go into the machine learning stuff. So codespell is an example of how you can write spellings. Let's go to that. I've already created this. This wouldn't have finished in one session. Let's go to the branch of codespell. Okay, I've already created this for you. Okay, so codespell, this will only trigger, mind you, this will only cause a change when you have some spelling mistakes. This will not work when you don't have spelling mistakes. Okay. This will run, it will show green, but it will not work if there's no kind of spelling mistake. So as you can see, its name is codespell. You trigger it on push or a pull request. Like there's some issue in the code, and you can see there's a spelling mistake in the code or something. So jobs codespell is again the, as we have done it in the how wala thing, that we had named it as basic, or even in the last one where I had written this name again. So yeah, codespell again. It runs on Ubuntu latest. By now you have acclimatized to how the syntax actually works. So we check it out, check this out again. So now we actually want to set up the Python. So we need the Python setup. So right, so when I'm using this means that uh, my runner now has the Python setup. It knows what Python is, what pip is. So now you can pip install easily. So what you do for that, you run pip install Codespell and Flake. Codespell and Flake are very famous Python frameworks. So these are like Python libraries. You can pip install them. So under this run body is what you want to do is you want to you want to do some skip creations. So using the skip creations, what you can do is you don't want to check those files that are belonging to some kind of, for example, you have this git ignore in GitHub. So skip is also kind of that kind of thing, functionality. So skip flag will do this thing. Quiet level 2 means it will quietly do this. It will not write any verbose. It will not write any logs. It will quietly do. It will uh, basically not create any outputs on the terminal. std output. Okay, so let's go to the action. Let's check out what actions have it for me. Uh, See, as you can see, in I had a file.py, so I don't I don't think there's going to be any. Uh, Let me name this as Nick. I'm not sure if this is going to work because this sometimes doesn't work. So codespell, I have made a commit. Now I'll be seeing an action very soon. Let's go to the action. This is running. This is on a queue. So as you can see, it's green. Okay, so it didn't find out any spelling mistake, but yeah, if you have some kind of spelling mistake, then it will be able to get triggered. So these were the set of basic actions that you needed to know. After which, I guess we will go directly to the machine learning actions. So for cron job for Python ML tasks, I will take you to one of my projects. It's this project. I'll share the name in the YouTube video in the description or either in the comments. I'll share all these report names. So it's the design lab. Okay. So what we had created in this one is we had created a cron service. So what the project here was is you had to do a credit card approval system. Okay. So for this credit card approval system is you need to okay, you need to. I'll just get down to the real stuff. You'll be able to understand. So my job name is Maven. Uh, I'm not. These are all just by default. It's Ubuntu latest, so you don't have to show anything. So what I'm. So yeah, as you can see here, like this is not an event based. This is an event based when you make a push, but under that you also you'll be able to see workflow dispatch. So what this does is they actually creates schedulers for you. Okay, so like example here you can see cron. So what this cron means, okay, so you might be having this question what this cron means. Let's go to cron tab guru. Okay, cron tab guru is the perfect place where you can check what this crons means. Okay, so my cron means it's very simply written at 12 next at 29th 8 12 12. So this means this cron will run every day at 12 o'clock. Okay, this will run at every day 12 o'clock at the 0th minute, 12th hour of that day, every month, and every day of the week. Okay, so for example, let me do this. Let me change this. Okay, let's change this and you'll understand. You want to just see the output. So let's change this that let's do this. So right now time is 22:22, so you can change the time as 24, and you can do this every hour, every minute of that hour. Okay, so let's do this. Let's change this, and I'll explain the rest part as well after that. I'll first make the commit so that I don't miss out that time. I want to see the workflow running live. So, time is changed. Time is changed. Yeah, timing has been changed. Okay, timing has been changed. Let me make the commit, and after that I'll just yeah. So as you can see, okay. So as you can see, what are my jobs is first you'll check out the repo. So you check it out. You set up the Python. So yes, now what kind of Python version do you want? You can specify that with 3.6 I want. I want to do the pip caching. So if you're not able to do the pip caching, you won't be able to install any recommend.txt files or something. So you need to do the pip caching. See, this is much easier than learning Circle CI or Jenkins CI or Travis CI because it's a functionality that GitHub is giving. So things are very manageable. Okay. So you can see that I'm pip install -r requirements.txt that we do normally, and after that you do this here, and you can do it here as well. It's just the same. And run source. So this is a token that I'm creating here. So run source is eucalyptus token. Eucalyptus token you can just write uh, any token like silly token or any kind of hack token. So any you can write just any name. Okay. So okay, so we have like created run src is your run src is your step. This your this your workflow. One of the step of your workflow that run src. Okay. So how do you want to run src? You want to run it using this token. So what it will do is it will get into the src folder and run the shell script. Same for the testing. For unit testing also it will do the same thing. It will get into the cd folder and do the run test. Okay. So as you can see, what we do is first we run the source code and then we run the tests. Okay. So what generally it should be having is when you see the output, it is like you'll see set of credit card applicant numbers, and beside that you will be seeing whether they have got the application successfully accepted or not. Like they're applying for a credit card, so you want to check, you want to predict. So this actually we are using tree-based models for that. So using that we check if they're getting those they're getting those credit card applications or not. So let's check the actions first, and then I'll show you the output. I'll show you the time as well. Right now the time is 10:26. So the timings changed. event has been triggered 45 seconds back, 2 minutes back when we were speaking. So you can see all have been correctly done. So install Python dependencies were there, as I was telling. Yeah, so you can see that files exist. Okay, so I guess these are just errors. These are just warnings. We'll go ahead and check the Drive HQ. That's where actually what is happening is we are using it in. We are actually using this in uh, an FTP server. Like what you're trying to do is we are trying to upload an application file to the FTP server. From the application file, the running is happening there, and then you upload that. You take the application file from the FTP server. Then you from there you start computing the stuff, and then you will be able to see this. One second. So, as I was saying that you'll be able to see you'll be able to see a data frame file that it will show all the credit card roll numbers and whether they have got the stuff or not. So I'll open this up and you will be able to see that uh, application ID and status. These are the application ID, and beside that you will be able to see the status. All right. So that shows like it's working. Like some have got this, some have got the stuff, some have not got. This was an edge case. They didn't get the application ID. It didn't get its application accepted. So this was the way of how you can schedule a job. You can schedule a cron service, and you'll be able to do this for other cases as well. So the next will be how to fetch metrics plots from a wine quality prediction task. So the next task that I want to show you is regarding how you can gauge the quality of your wine. So for that, I'll take you back to our SillyHacks practice repository that we were showing you earlier. So earlier I had gone to the wine prediction. Yeah. Okay. So what I've done here is I have wine quality CSV file. So I'll show you the data frame. So this is your acidity, density, pH value, the amount of alcohol, the quality, chlorides, residual sugar. These are all your numerical variables in your data set only. So you create a tin.py and you train it. So you want to test it again and again. So here I'm using an RF regressor. I'm a random forest regressor and I'm predicting it. So these are, I'll also plot the residuals. I'll just plot the residuals here. So this is something that you normally do in machine learning. And what I'm going to do here is, let me make just a small change so that you can see whether the values are same. Like I'll just change it 42 like 41, and let me change the test size to 0.1. Okay, let me change the test size to 0.1, and let me change the max depth to depth 3. Okay, so let's see how it has fared. I'll make the change. I'll create a new pull request, or I already had created a pull request. So as you can see, this is running because I'll also show you what workflow that I was using, because right now we are talking about machine learning here. So I'll show you the workflow as well. It's this one prediction. Yeah. Okay, so it's the wine.yml. Yeah. So it's your wine.yml. It's your secrets.github token. As you can see. So right now we are using a container. We are not using your normal workflow runner. We are using a Docker container. So you're using the DVC organization CML Pi3. So it's the CML is a very famous framework that DVC organization has provided. CML allows you to have a Docker container. So inside a Docker container, you will have a GPU, you'll have all the NVIDIA files will be there. So you can also do deep learning with this. So we'll create an actions runner. You'll create that name CML run. So your workflow name, your workflow stuff. All even if you create a pipe like this, you can write all the stuff below that. So pip install requirements.txt. You run the train file, and then your model metrics get outputted to a markdown file. Then that those values are your metrics.txt. So your report.mb will be basically a comment by your GitHub bot. It will start with a model metrics as your heading, and then the metrics.txt will be plotted there. After that, data visualization will be written as a subheading, below which your CML publishes a function that will paste all these images. It will paste these images into the markdown file. These are two images. The feature importance in your random forest, you will have this feature importance, like which feature is contributing more towards the prediction. So you'll have that feature importance, like horizontal bar charts, and on the last you'll see that there will be a comment that will be created by Y. So let's check the okay. Okay, update train.py. You can see there was a commit that was created. So this was the update train.py that we created. It's 17 seconds ago this was created. So you can see we had made some changes. Earlier the change was 41, 42 and 41, and the test size was 0.2. So now my test size is just 10% of the total, and my max depth of that tree was 2. Now it's going to be 3 in the random forest. So your model metrics, your variance has changed. Your test variance has been explained better. 30.5%. You can see the random forest feature importance. You can see alcohol comes the most importance when it comes to predicting the wine quality. As you can see, the residuals, true wine quality and the predicted wine quality. So this is a very nice visualization tool and a very nice machine learning orchestration framework. This GitHub Actions. You can run these workflows on the go. You can make small changes instead of like, okay, like you made this change, then you'll like get pull this changes into a local remote. Then you'll run Python train.py, after which you'll get those nice looking plots, and then you'll see them, and then you have to save them somewhere. So you'll run this n times. You have to save the same images n times. So instead of doing that, you can like have these as commit comments. Whenever you create a commit, those will come as comments under that. So you'll be able to see them very easily. Okay. So this was a nice way to show metrics and plots. I'll also show how we used machine learning and deep learning projects in our lab. So I'll just go to our yeah. I'll just get to our DL GitHub Actions. So this was I created this just a while ago. So even all of these are like my accounts only. So what we are trying to do here is we are trying to check the classification, how much classification has happened, like what is the classification accuracy, what is the uh, number of classes that were like having better accuracy and stuff. So we'll check all that. This is a framework that is already used. So you can see in the GitHub workflows. So you can see here, I have named this as demo. Both of these are my accounts. So you can see that the name is demo. You can see that we have triggered this on a push trigger. So this will run on Ubuntu latest. Then again, for deep learning projects, we need to create a container because we need NVIDIA Docker. We'll also need uh, all the CUDA libraries for that if you want to use GPU. So I need this Docker. So after that, I've created actions checkout. I've done this CML run. Again, I'm using the same authorization token. So I'm just doing the requirements.txt so that I have um, all the dependencies like PyTorch and all. I'll need that. Okay. So I'll do this pip install requirements.txt. Then I'm downloading the dataset. So in our lab, we work on hyperspectral imagery around. So hyperspectral imagery, like you have an 200 or 300 channel image, and then you have and then you have ground truth for the what each pixel, which class it corresponds to. So we have the ground truth file. So it's a very popular data set is Indian Pines. So you'll see the Indian Pines data set, and then you'll see the Indian Pines ground truth for them. So we are downloading that. So you can see the duplicate command for them. So we'll get inside this srnn folder and we'll run the indian.py file. So once I'm completed the run, it will take a lot of time. So I'm going to just show you the output because it's like there are three iterations, and every iteration will have 200 epochs. 600 epochs is going to take a lot of time. So you see I'm writing the CML report here. You'll see that the CML report I'm saving this the file that will be created in this india.py. So I have to cat that and put this into a comment report.md, and then send comment report.md will create some written comments on that. So I'll just go ahead and show you the whenever like you have a comment, you can see the comment here as well. So you'll see the commit ID, and you'll see that yeah, this is work properly, and you'll see the stuff. So cml.yml, cml.yml, and I have not made any changes last time. So when I was running this, so you can see the run was completed last time properly, and you can see GitHub Actions is commented properly. You can see the overall accuracy after, as I said, three iterations. So these are the three iterations: overall accuracy, average accuracy, the kappa score. Average accuracy is the class-wise accuracy, and you can calculate the mean. So there will be the mean and the standard deviation will be created for all the three metrics. The average testing time, this is in seconds. This is the testing time, training time. So these are the mean values in the confusion matrix. So Indian Pines has around 16 classes. So you'll see 16 values here. So every mean value will also have the standard deviation. So 16 values here. So that's it from me. I guess there were a lot of ups and downs in this workshop. This always happens when you're working with GitHub workflows. You can have syntax errors. Uh, you can have some issues like okay, well, this comes after that, this comes after that. So everything like this is totally a practice based. You should just keep practicing this. You'll get to know this more. Even in a hackathon, like when you're trying to like test something very uniquely that you've thought. Okay, you don't have time to again run it again and again. So you can use this DVC or CML. This is very handy. It gives you NVIDIA Docker, so you can use it again and again in your hackathon. This will be very useful, very useful. And that's it from me. If you want to know more, and you can check my GitHub and you can message me there. I've attached all my contact pages there. And thank you for being with me because there were a lot of ups and downs in this talk. Uh, because I also like get forget the syntax, or I get slowed down a lot. So thank you for being with me again. If you have any questions, please let me know. Thank you.
Hello. So it was a really good talk, and for someone for someone who's just starting out, it is like this is the place someone can reach. Like who's someone who's starting out with GitHub Actions or with Hemen. So Sayantan, if you could tell me that, how did you end up into ML? Like what fascinated you? You were muted. I'm sorry, you were muted. So
Yeah, so I got fascinated with machine learning when I saw these uh, yeah, interviews with Elon Musk, and he's talking about changing how changing the next world with new technology. Like
yeah.
machine learning, artificial intelligence. So I was like, okay, what is this kind of a thing? I have never heard of this. So that was, I was in my second year. So then I started learning stuff. Everybody starts with that Andrew NG course, and then they decide like what they want to like work on. So I got really interested in imagery, videos, and computer vision in general.
Yeah.
So that's how everything started.
ML is indeed fascinating, and like
Definitely.
hopefully it is the future. So I don't think we have like we do not have any questions so far. So if any one of you has any doubts, you can still ask us. We are active for about 10 minutes. So if you have any questions, and also there's a link to the repository Sayantan just introduced. So if you want to go there, have a look at, or you want to start with the stuff. And yeah, Sayantan, so you told me before this talk, like while we were just having a chat, that you do research, right? So what kind of research do you do?
So I generally work on satellite imagery. It's part of the hyperspectral domain. It's not like RGB images. So these images generally have around 100 to 200 channels. So the main problem with handling these large amount of channels is there will be a lot of data discrepancy, and you cannot handle such a large image. Like if you want to
Right,
like create batches of that and feed it to a neural network, it will have a lot of memory overflow. So you need to do some dimensionality reduction techniques. So that is one kind of research that is happening. And the other type of is through these satellite sensors, you want to like classify the entire Earth's map, everything,
okay,
from building footprints, from like change detection. Like recently there was an accident in Lebanon regarding
okay,
there was a explosion in Beirut on the port. So that
oh,
actually caused a lot of ecological issues as well. So
okay,
we can like do change detection on that, like before image in and after the incident we can take that image and we can do some kind of a segmentation approach on that. So that is
okay.
also a domain specific research.
Right, right, right. And I also had one question. Since you are fascinated by Elon Musk, and since you have interned in ISRO, so if you could tell me about that experience, how was it for you?
Yeah, so I worked at the microwave remote sensing department. So my work
Mhm.
was mainly on microwave imagery. So microwave imagery does not work normally like what we see the RGB imagery. They are outside the visible
Yeah,
spectrum.
right,
So
right, right.
the acquisition techniques are very different. So I was at the
Mhm.
Space Application Center at ISRO Ahmedabad. So
Okay,
they totally work on our Indian satellites are RISAT 1, RISAT 2, and RISAT 2B. So
okay.
these are actually private data sets, but if you are an intern, you can like get a temporary access for. So I was there for
Oh,
around 2 months. I had worked on deep learning applications, and I had also worked on like ground detection. Like you have to detect any moving targets. Like there's a ship, so the entire department has actually started after the 26/11 attack in 2008. So they
okay,
wanted to like focus on the military defense part of the satellite imagery. So my one of my subtopic of my work was identifying ships, identifying boats. Like if
okay.
you have like yeah, if you have like two images which are temporally different, like around 16 days past, so you can like find if there are any moving boats, moving ports, and moving big ships or small ships. So that is very important because it's very
Amazing.
related to the national security.
To me, it is like I'm a layman in ML, right? But it really sounds pretty fascinating. It's really amazing what you're doing, and we hope you have fun in your future ventures and everything. So
Thank you.
we do not yet have any questions, so I guess we'll end this session here. So if you have any last words or anything you want to share with us, for someone who's just starting out with ML, you can
First
do
of all,
that.
I would like to thank SillyHacks, Devansh, Arpit, Arpan, and everybody, Fenil and the team for a nice onboarding before the speaker event, and I really liked how they had actually approached me. I had like accepted the proposal, and I had uh, gone with the pre-recording and everything. The logistics were excellent, and I would like everybody to participate in this silly hacks. It's going to be an exciting hackathon, and because I have also taken part in many hackathons, so I am really excited when it comes to hackathons. Yeah. So
Okay, so for the viewers, we did not tell Sayantan to tell this like market chili hack. So it is all him. So if you go by his word, you should register. And thank you, Sayantan, for joining us. It was great
sure,
to
sure,
have you.
sure.